Welcome to the fourth in our SenixVIEW video tutorial series, Setting Up Analog Outputs. As before, we begin in the main workspace window, and the first thing we need to do is connect to a sensor. This time we'll do it using the shortcut, simply clicking on the sensor icon. This takes me to the setup of the last sensor I was connected to, and will allow me to connect and to copy the sensor setup to workspace if I choose. These were both in the default configuration before beginning. What we're going to do is make changes now to the analog output. And let's suppose that we have a tank and we have fluid in the tank that varies from 8 feet when it's empty to about 1 foot from the sensor when it's full. So let's start by changing the near value endpoint to 12 inches. That is the low value endpoint at present. And let's take the high value endpoint, or more distant endpoint, and let that be 8 feet away. And let's assume that we really want to have the output high when the fluid is high. So we will right-click on either the low value or high value endpoint lines and choose to invert. So now we have 10 volts or 20 milliamperes at 12 inches or high level, and 0 volts or 4 mils at the low value endpoint or low fluid level. You'll notice that we have not equal signs here between the workspace and the sensor and the workspace and the file. Let's right-click on the workspace icon and drag the pencil to the sensor. And we could right-click here and drag the pencil to the file as well. And that will allow me to name this file. And I actually have an analog setup configuration here. So I'm going to use that name, and I will overwrite the prior file. Yeah, let's edit it. You can put in anything that makes sense, obviously. So now we theoretically have a sensor set up the way we want it to be. In the previous sessions, we've configured the sensor, perhaps slowed it down and put in some signal averaging. Now we want to know whether our wiring from the sensor to our indicating device, be it a meter or a PLC, is set up properly, and whether the meter or PLC is scaled properly. We have an output test for that. Click on Workspace, click on the Sensor menu, and come all the way down to the bottom. And in this case, let's say we're taking 4 to 20 milliamps. I'll choose the current test. We can start at any value we choose. The default is 4 mils. The ending default is 20 mils. It steps in 1 milliampere increments unless we tell it something else. And it currently is delaying 3 seconds per step. You could make that be a very long step and have the start and stop be the same value and just output a single value that way if you wanted. But I want to go from 4 to 20, and let's speed it up a little bit, spend a second at each point. And I've got a particularly long system wiring with some junctions in between, so let's loop on the test and give me plenty of time to verify. And you can see that on the replica meter here that our current value is stepping up in 1 milliampere increments. And this will continue as long as you need it to until you're able to verify the wiring and the scaling on your display device. So let's stop the test. That test is done totally independent of the analog signal that might come from the sensor. And now we can see that our fluid level, or our ubiquitous wall, is still 6 feet away. And that corresponds to something on the order of about 8.5 milliamperes. We can find out exactly what that is by clicking on the large display and choosing current. I did that when you weren't looking. That's why it came up. Normally it would be in the distance mode. But we see that it's 8.59 milliamps. So that's the basics of setting up a sensor analog output. One other thing to touch base on is the analog window, the analog icon. Here you can choose the value that the analog output will go to upon power up. Could be voltage low or current high, as the case may be. And for right now, I'm going to assume that it's current high. And the reason is perhaps our PLC is controlling a pump. And we don't want the pump to turn on immediately until we've had a good set of data given to it. Perhaps we're taking a running average and it might take 10 seconds to get solid data. There's no point in oscillating the pump while that happens. Also, if you lose target, and in some circumstances you can lose it in a temporary way, like, for example, filling a tank might cause some turbulence, we might want to hold the last reading or go to a low value or a high value. And we're going to leave it at hold since that's the default. We can also program a delay. If the target is lost, we can tell it to wait a minute before it does anything. And so let's OK out of that. And in both cases, we have non-equal signs, so let's copy it to the sensor. And in this case, I'm going to go to the File menu. I'm going to click on the workspace first, and then go to the File menu and save workspace to disk. And I'm going to overwrite that same file one more time, and I'm not going to edit it this time. So those are the basics involved in setting up an analog output, current or voltage. In our next session, we'll look at setting up switches.